So January 2018 paper. Which electrode and solution would be used to measure the standard electrode potential? Look, one thing which is very important to understand the concept of electrode potential. Here, there is a change in oxidation number. Like manganese, if it was like example, manganese ion or atom was involved, then the electrode should be made up of manganese. But only if there is a change in the oxidation number within the solution. So in that case, electrode should be made up of platinum. So either C can be an answer or D can be an answer. Then why D is the right answer? Because whenever we are finding the electrode potential in the solution, we should have equal amount of two ions. Like we should have Mn plus 3 ion and Mn plus 2 ion in equal amount. And we dipped a platinum electrode so we can identify what is the tendency, whether manganese 3 can convert into manganese 2 or opposite can happen. So we should have two ions in equal concentration, as well as the electrode, because there's a change in oxidation number, so electrode should be made up of platinum. If there was no change in oxidation number, like if atom was formed during the oxidation or reduction, then we should use electrode also made up of the metal. In which pair of oxidation number of a D block element same? So oxidation number is a charge appear on the element when it is like using a number of relative bonds. So when we check, see, ammonia is a neutral ligand, overall charge on the complex is plus. Chlorine, each chlorine is -1, so 2 chlorine will be -2. So what should be the oxidation number of chromium here? +3, because overall is +1. Here, water is a neutral ligand, so manganese should be +2. So the two metal does not have the same oxidation number, so it is not. When we check the second one, in CrO4, overall charge is -2. So one oxygen is -2, 4 oxygen will be -8. So chromium should be +6. And in titanium chloride, each chlorine is -1, so 3 chlorine should be -3, so titanium should be +3. So it is not same, like chromium is +2, titanium is +3. Then we check for option C, chromium 3 oxide. Each oxygen, overall molecule does not have any charge, so it means the net or the overall oxidation number should be 0. The sum of oxidation of, so one oxygen is -2, 3 oxygen will be -6. So chromium should be +6. And like 2 chromium is +6, so each chromium, we are talking about each individual, that is +3. Because 2 are +6, so 1 will be +3. For hydrogen cyanide here, iron complex with nitrile cyanide group, so that is this each is -1, so 6 will be -6. And overall is -3, and iron should be +3. So here chromium is +3 and iron is +3. That's why C is the right answer. This question, 1 mole of a metal reacted with a solution of 1 mole of sulfur dioxide. The half equation is there. The original oxidation number of a metal is +3. So how to identify the dimension? Like there is a metal reacted with sulfur dioxide. The final oxidation, the original oxidation number is +3. And the ratio between them is 1:1, like 1 mole of a metal react with 1 mole of sulfur dioxide. So if sulfur dioxide will lose electron, metal will gain electron. So how many electrons sulfur dioxide is losing? It's losing 2. So how many electron metal should gain? The metal should gain 2. So if metal is already having a +3 charge and it gained 2 electron, so what will be the final oxidation number of the metal? That will be +1. So A will be the right answer. For example, if the same question was there and they say like 2 moles of sulfur dioxide reacted with metal, 1 mole of a metal. So if 2 more, like this equation was there, and in the question they say 2 moles of sulfur dioxide instead of 1 if it was 2 moles. So if 1 sulfur dioxide is losing 2 electrons, 2 sulfur dioxide will lose 4 electrons. And if they are losing 4 electrons, they should gain 4 electrons, and there will be a charge of -1. But here 1:1 is the ratio. So how many electrons lost by sulfur dioxide? Same number of electrons gained by the metal. Then question 4, this question related to a complex which is tetrahedral. Tetrahedral, basically it should have a 4 identical ligands should be attached. So A is a tetrahedral. What about copper chloride? It will be a linear. Platinum, it's a planar. And this is octahedral because 6 ligands. Platinum all are planar. Copper chloride, it will be 2 ligands linear, and this will be tetrahedral. It is same like how many bond pairs are attached to a central atom. Using that idea, we can predict the geometry of a complex. Which complex contain a metal with oxidation number of plus? So we have to again yeah, that's right. B is the correct answer, because when you check, overall is -1. So 1 chlorine is -1, 4 will be -4. So chromium should be +3. Here 1 chlorine is -1, so 2 -2. So copper should be +1, because the overall is -1. So the resultant, the sum of the oxidation number of metal and non-metal should be -1. In this, so copper should be +1. So B is the right answer. Here, this is a neutral ligand. This will be -2. So platinum should be +2 because overall it is no charge. And here -6. So this should be +4. So overall will be 2 minus or -2. An ion of a metal has a charge of plus. It forms a complex with a bidentate ligand. Bidentate ligand means like how many ligands could be attached to it. The formula of a complex ion, formed between the metal and the bidentate ligand is Ml2. What is the charge on the ligand? So how we can work out the charge? Look, we have M and we have L2, and the overall net charge, it is N+4. Okay. So they mention an ion of a metal M has a charge of +N. So the charge here is +N. Okay. We want, like we don't have this, we don't know this. So each is X, but there are 2 ligands are attached, so 2 will be 2X. So I can say N plus 2X is equals to N+4, because the total sum of the oxidation number of the metal plus the ligand will be equal to the charge on the complex, which is N+4. I want to solve for N. So I want to solve for X. So N will cancel with N. So 2X is equals to 4 plus 4, or X. So 2X is equals to +4, or X is equals to 4 divided by 2, and X is equals to 2. So means the value of the X here should be 2. But whether it is +2 or -2, this can never be an answer. Why? Because the ligands cannot have a positive answer, either they will be neutral or negative, because they tend to accept the proton, or the lone pair, the metal will have always have a positive oxidation number, and these ligands will have a negative oxidation number. So either it can be 0 or it can be negative. It cannot be positive. So 2 is there, so it means -2 will be the right answer. Then question 5, part B, another complex ion is there form in which both of these bidentate ligand in Ml2 are replaced by a neutral monodentate ligand. What will be the formula? Look, bidentate ligand means they can form a bond from two sides. That is bidentate. But if these bidentate ligands are replaced by monodentate ligand, so if there was Z is there monodentate, so the coordination number, it will form 4 bonds. The number of the dative bond does not change. Only the number of the ligands attached will change. So if bidentates are replaced by monodentates, so how many monodentate will be attached? It will have 4 monodentate ligands. So this will be Z, this will be Z, this will be Z, and this will be Z. And what is the formula of this complex? So it contains metal, it contains 4 monodentate ligands. And what will be the charge on the complex? Because this is a monodentate ligand. So, and the charge on the metal was N, that they already mentioned in the beginning. So what is the total charge on the complex? So that total charge on the complex will be N plus or plus N. So that's why C is the right answer for this. Then two solutions of a copper sulfate. One is forming a brown solid, and the other one is using a potassium iodide, it is forming a white solid. What is insoluble solid E? Brown solid. What is brown solid? Basically reduction happened. Copper 2 is blue in color. So when copper 2 is blue in color, this copper can be reduced to copper metal, which we say brown or pink, or copper can be oxidized to copper 1, and copper 1 oxide, because there is no complete why its appearance will be white solid, because there is no d orbital, empty d orbital electron. That's why it will be a white solid. So compound which contain copper 1 should be a white solid, and a compound which contain copper as a metal should be brown. So they're asking a question, what is the insoluble solid? Brown solid. So what is this brown solid? That is actually, because zinc is more reactive, if we have a copper sulfate solution and we add zinc metal, zinc is more reactive, it will displace the copper. As a result, it produces zinc sulfate and copper metal. So that's why A is the right answer. And the second part, what is insoluble white solid F? So white solid F is actually iodide ion is good reducing agent. So it will convert this copper 1 into copper 2 into copper 1, and it will form copper 1 iodide, and copper 1 iodide is white solid. White is white. The reason they can ask, so the reason white is white, because it is not having the partially filled d orbital. D orbital should be partially filled for forming a white, like it should be partially filled to form a colored compound. But d orbital, if it is completely filled or empty, then it does not form a colored compound. Then a benzene react with a mixture of nitric acid and sulfuric acid. So what are the reactions of benzene? Benzene reactions are electrophilic substitution reaction. So B is the right answer. That in the benzene topic, you will learn that the reaction of a benzene are electrophilic and substitution. Then a benzene react with phenol with bromine. So organic product, when benzene react with excess of a bromine in the presence of ultraviolet light. So what is the observation? What is the product form when benzene react in the presence of ultraviolet light? Actually, benzene will convert into cyclic alkane and all the bromine molecule are added. So D is the right answer. This is related to reaction of a benzene. If this is a limited supply of bromine, like this happen. But if we have access of a bromine and ultraviolet light, all the bonds will break in benzene and it will convert into. No, it will be 246 if that is there if we use a limited amount of bromine. But here, what is the organic product when benzene react with excess of bromine? Excess of bromine, and in the presence of ultraviolet light, it will convert into cyclic halogen alkane. It will be 2, 4, and 6 when alcohol, if it was a phenol, if it was a phenol and we add a bromine, then it will be 2, 4, and 6. But this was directly they're asking about the benzene. Then bromine react rapidly with phenol, then benzene. This is because, what is the reason why bromine reacted? So the reason is that because this contain, due to phenol, the OH group is attached. So the lone pair of electron on the oxygen atom overlap with the d orbital. Because these lone pairs overlap with the d orbital of a benzene ring or delocalized benzene ring, that's why it will make it more reactive. So this is, you will, when you go through the benzene topic, you will find that this reason is always there.